Unifu College of Artificial Intelligence, which is based in Nairobi. I'll be handling the basics of what is data science. Also, I'll introduce you to what is full stack data science, and I trust you'll handle some of the most important questions or the frequently asked interview questions in data science interviews. So yeah, the questions were sent by someone, yeah, and the person who sent the questions also compiled some notes and answers and materials. All the notes that we'll be using are available on the GitHub, and I'll start by sharing so that anyone who wants clarification can get it from the notes that I'll be using. So also, you should know that the event today is supported by Next Africa. Yeah, I've shared their Twitter handle on chat box. So basically, Next Africa is concerned with all its major emphasis is on building smart systems. Yeah, they are based in Thika, Kenya. So we can start the meeting by me sharing first my screen. Yeah, I want to share my screen so that we can start. So can someone confirm if they can see my screen? Introduction to data science. I want to be tackling anything in depth about data science. Can you see my screen? Unmute your mic and reply if you can see my screen.
Yes, yes.
Okay, thank you. So I'll start by discussing what data science, but I think a lot of you, if you're here and you have been in the bootcamp for the last 10 weeks, for the last 6 weeks, you basically have that understanding of what data science is. Okay, I'll start by defining what data science is. Data science is the domain of study that it deals with vast volumes of data using modern tools and techniques to find unseen patterns. So what you're looking for when you're studying that large volume of data, you're looking for things like unseen patterns which human eye can't see. So you want to analyze that data that you have so that you can have some meaning, or you can derive any information from it to derive meaningful information and to make business decisions. So basically, data science uses complex machine learning algorithms to build predictive models. A good example is like you're given an example where a retailer is giving you is or a data so that you can analyze and help her to get in touch or to maintain some customers who are buying products from this solar shop. So there are very important technical concepts that you should know in the field of data science. Some include machine learning, yeah. The other one is modeling, statistics, programming, and databases. These are the basic technical concepts that you should know as a data science. And you know, as a data scientist, you need to have a solid grasp on machine learning, in addition to basic knowledge of statistics. So that should be one of the things that you know if you're in if you're in the field of data science. The other thing that you need to understand is the modeling. So this is where you use the the mathematical models enables you to make quick calculations and prediction based on what you already know about that data. You already know basic information about that data. Now that is where you derive mathematical models so that you can have quick calculations from the data. Modeling is also a part of machine learning, and it involves identifying which algorithm is the most suitable to solve a given problem and how to train those models. You know, not every machine learning algorithm is suitable for solving every problem. Each machine learning algorithm or model has its own application and problems which it can solve. The other part is the programming part. Okay, if you're in data science, you should at least be able to program using at least Python, R, or also SQL. Those are the basic one. But also you can do with machine learning. And on the programming concept, that way we are introducing the part of, at Data Science East Africa, we are introducing the concept of having to run C++ for machine learning, and that will start next next month, next month, around 20th. You're beginning the first bootcamp for machine learning using C++. The other thing that you need to know in the field of data science is databases. This is where you keep your data, how your data is organized. So as a capable data scientist, you need to understand how databases works, how to manage them, and how to extract data from them. Like you as a data scientist, you should at least know how to write a Python program. You should at least know how to write a Python program that can extract certain or specific data from a MySQL database or any other database that you're given that stores your client or customers' data. So you might ask, if I'm a data scientist, what will I do at work? So these are some of the most, okay, these are some of the things that a data scientists do. They include asking the right questions to understand the business problem. They have to gather the data. Like I might ask you, who knows where you can get the Kenyan data? Where can you get data about Kenya? Anything you want to know about Kenya? Anyone with the question, you can type on the chat box, I'll look. Anyone who knows where you can get any statistical data in Kenya or in any government?
Maybe I can make a trial. The Kenya Bureau of Statistics and also the government institutions. For example, if you want the data concerning security, the Ministry of Interior and Coordination, Interior Security and Coordination, you can get it there. And also, if you want like for some organization, or maybe you want data on something concerning Kenya, you can also scrape it on websites or from websites.
Thank you. Anyone with another solution? You still can see my screen that I'm sharing, the page that I'm sharing. So we have this website. I think, yeah. Every government has that repository or a website where they keep their own data. It is called open data. Even if you want for US, you can get it from opendata.go.us, the way they do their domain. So open data for every government, that is a necessity, so that you can get any data that you need about a specific. Yeah, you can see, like if you open the opendata.go.ke, you can get a lot of data about Kenya. There is agricultural data, education data, energy data, health, water, all all types of data that you need, and you can browse all categories. So it's not limited to the only ones that are shown here. There are a lot of data, and you can download them in many formats, maybe CSV, any format that you want. So I was here on the part of gathering the data from multiple sources. So the other one, after you have your data, you have to process your data and convert it into a format that is suitable for analysis. So after you have asked the right questions, you know the data that you use, you have gathered the data, the next step will be to process the data. After you have processed the data, now here where you feed your data into analytic systems. This is any machine learning algorithm or statistical model that you have developed. Maybe you wanted to predict your data using maybe linear model, like, yeah. So you feed now your data to that model and get the predictions. So the last thing after you have done that, you prepare the result and insight to share with the appropriate stakeholders. So this is just a basic one, or just a sketch. You can call it a framework of some of the things that a data scientists need to do. There are some that are not included. Like if you build your machine learning algorithm and it has to be deployed in production. Yeah, now where there is where the need of a full stack data scientist comes. So because this is just on the basics, also I will cover some of the basic machine learning algorithm that a data scientist need to know. Some include regression, clustering, decision tree, their support vector machines, and naive Bayes. So you can look at this later. All the files that I have are in this file that I've shared with you. You can get them there. You have the link that I've shared right now. Do you? Hey guys, make the session interactive. Have you seen the link?
Yes, yes,
Yeah,
we've seen
thank
it.
you. You can open it. There is data that you need to know. Let me now share the next page so that we can start looking at exactly what is full stack data scientist. Now you can see my page that I'm sharing.
Yep.
Hey,
Yes.
okay, yeah. So now we can start asking the big question that a lot of people have wanted to know. What exactly is who exactly is a full stack data scientist? And maybe before I share, you can give tries. Let's see who has a solution. Maybe you can type your answer. Who do you think a full stack data scientist is? Just make a guess. What do you think a full stack data scientist is, and what does they do at work? Like, if you're a full stack data scientist, what do you do at work? Kindly share your feedback on the chat box. No one as a crew. Just how do you understand full stack data science? Okay, then we can go on to full stack data science. Yeah. So if I'm talking of a full stack data scientist, I'm talking of someone who can do the whole process of data science, from problem definition to deploying the model, to controlling and monitoring the deployed model, to make sure that the prediction are correct, even if the input or the characteristics of input ever changes in future. So those are the laws of a full stack data scientist. But I can tell you that this comes with experience. Like, you don't have to start like a full stack data scientist. Just start from somewhere. Start by doing something. make sure that you're perfect on something that you're doing currently, and now keep adding the skills that you need. Like start by defining the business problem, collect the data. After collecting your data, clean your data. After cleaning your data, now you can move to where you can model your data. After modeling the data, now you can learn maybe a web framework, any like Flask and Fast API. After learning a framework, now here is where you serialize and okay, you can use libraries like Pico if you're using any Python framework to deploy your model. Now, I'm not talking, yeah, if you're in her language, you know about collect and the whole pipeline from data collection to deployment. But today I'm talking about in respect to Python. That's why I'm talking about something like serializing your model and deserializing it. So after that, you have to deploy it. After deploying it, it makes collection. Now it is there, but you know, as usual, data changes. Data can change. The way people preferences can change, the same way with how data changes. So if data changes, will still the model give the correct predictions? Now, there is where you come with the need of monitoring and ensuring that your model gives the correct definition, regardless. Yeah, I wanted to check that message. Yeah, you can use even dash. But I prefer if you're starting, I would recommend you know how to work with web. You know, even that one will make your work easier when you're getting the data from the website, like web scripting. Yeah, if you understand basically how a website is built as a data scientist or machine learning engineer, you can understand even how to script that data, to scrap that data from a web page. So I think I'll start with my strengths where I've defined a full stack data scientist as a jack of all trades. He or she engineers the work and works on each stage in data science life cycle from the beginning to the end, as I have said. So he is involved in every data science process. And the scope of a full stack data scientist covers every component of a data science business initiative, from and training to training to deploying the machine learning model that provides a benefit to the stakeholders or to the to the business. There is something else I wanted to talk about. If you're a data scientist and you're given a task, they don't want to see the correct predictions. What they want to see is your ability to transform their data to money. What they're interested in is not the right prediction, the right machine learning model. They are interested in your ability to transform the data that they are given you or the data that you have access to how can it generate income to the organization that is there. Later, I will be giving you examples of how you can apply data science in real life, examples of project I think you can build and generate for you income. So in general, we can say that a full stack data scientist is someone who takes a data-driven concept from identification or ideation, where the idea is, where you give birth to that idea, or where the problem is identified, through to execution of that result in some tangible, measurable, and impactful improvement. There is a heavy emphasis on being able to drive an organization to do something, not just analyze something. In technical sense, full stack in the data science stream has a lot of parallels with the descriptions of full stack developers, one that can handle all aspect of technical development process. So as a full stack, maybe engineer, as a full stack data scientist, you have the ability to handle any process, any technical process that you encounter in your development process. And these are the basic data science life cycle. It is not mandatory to use this life cycle, but I have defined it according to how we conduct the data science process at Next Africa. So we start by identifying the business problem. After you identify the business problem, now you collect the data. So after you identify the business problem, you collect the data. After collecting the data, now there is where you conduct the exploratory data analysis. After analyzing your data and making sure that the data are ready to use or to consume in machine learning processes. Now, there is where you start the machine learning, like you're modeling the data now, the data that is clean. Then after you model your data now, there is where you start by analyzing your models and the acceptance stage. You know, you can't go on if the model results are not accurate. So after you model your data, you have to analyze your data and make sure that they are accepted for the next stage. And the next is the most important stage, model deployment. Yeah, that is the most important stage. It is even important than collecting your data. What if you collect the data, you analyze your data, then you train your machine learning model. It is predicting very well, 99% accuracy. Lakini bado iko, the model is still on the Jupyter notebook. What of use will it be? Taking to that business person a project that is on Jupyter notebook and telling me to learn the project that you see that the analysis, the model is predicting accurate. Make sure that you know or you learn or you start learning. It's not too late to start. How to deploy your model. There are very many examples, especially with now that we have something that is called machine learning ops. That is ML ops. Sorry. There is this term and there are ML ops softwares that were introduced. So you can look at some of the available softwares for machine learning operations. So I won't be discussing this process in depth. I want to move very fast so that we can go to interview question. That was our main agenda for today. So the life cycle, I think you have understood. You deploy the model. After the model is accepted for the next stage, then after deploying your model, you monitor the model to make sure that it maintains or it continues giving the correct prediction, regardless of any change that may occur. So I think I won't touch on them, but I will mention them again. This is how the data science process is done at Next Africa, which they inherited from Data Science East Africa. They are the same, one organization. So we have business problem, where you define the problem that is there to be solved using data-driven concepts. Then after that, you collect the data. Then after collecting the data, you analyze your data again, machine learning, where you model your data, you're training your data. Then you analyze the model, and if it is ready for acceptance, or if it is ready for the next stage, that is the acceptance phase. Now you deploy the model. After deploying the model, now you monitor the model to ensure that the model behaves as expected in future. So there's something that is said that a full stack data scientist is a jack of all trades. I even mentioned it in the beginning. So these are some of the skill set that a data scientist is required to have. Like one, a data scientist is required to have business acumen. This is understanding and relating very well with the business side of the process. So a full stack data scientist must be able to identify and understand the business problem and the opportunities that can be solved using data science toolkit. So As a full stack data scientist, you should be able to understand and identify any business problem or any opportunities that are there that can be solved using data science toolkit in order to prioritize project and processes from with most values to their organization. They must understand the names and the goals of their organization. So as a full stack data scientist, you have to understand why did the business department give me this data so that I can analyze what do they want to get. Those are the goals and the needs of any organization. Then the other thing is the collaboration skill. This is very important so that you can relate very well and work healthily with other data scientists, maybe machine learning engineers, I can call them colleagues, and the business stakeholders. So a full stack data scientist collaborates with the stakeholders to identify existing problems or inefficiencies that can be solved with data science. And once the problem are identified, collaboration is essential to ensure that the result is acceptable and meet their needs. So you have to work with everyone who is concerned in the business, like to make sure that you don't make rash decisions that affect the income of the organization or that may cause losses in the organization. The other thing I want to talk about is communication skill. I was reading this article by, oh Jesus, is it IBM? They were saying that I will share by the head. They were saying that communication skill is one of the most important skill that a data scientist require, especially in this 2020-2021. Then the other thing that you should know is programming. As a full stack data scientist, you must be able to write clean, efficient, object-oriented code that works reliably in production. Now, this is where I was telling you that you should know how to deploy your model. Instead of using those automated tools that are there to deploy your model, you can start by deploying a simple model using maybe Flask, maybe Fast API. You can also use Dash, but you can also go a point further and learn maybe DevOps and understand how you can deploy a model using some tools like Docker. They are very important for data scientists, and they will help you to stand out. Honestly speaking, I've interacted with a few guys, and knowing these cloud tools and technologies, knowing how to use Docker as a data scientist to containerize your model and being able to deploy them in any cloud service that is there, it has helped a lot of data scientists earn their job. So another thing that I would like to mention, this is mentioned everywhere, that is data analysis and exploration. Then the other thing is, as a full stack data scientist, you should understand machine learning and the statistic very well, in depth. We'll look at it later in the questions. Then the last thing that I'll emphasize on is deploying your model and data engineering. So I would like to end with these 2 points. Yeah, they are the takeaways that I want you to have in all my talk. If you understand this, will be going to go. A full stack data scientist goes above and beyond the typical data scientist role in 2 ways. The first one, they link the business needs to machine learning solutions, or data science. Okay, there is this concept that everyone thinks that data science, maybe it's a must to use a machine learning model. You can use a statistical model, yeah, and you can feed the data and it can predict very well. But currently, everyone feels that there is need for applying machine learning in every problem that you have. It is very important. So that's why you see, when I said A full stack data scientist links the business to machine learning. Okay, I said all not machine learning solutions because I don't expect every data science problem to require machine learning in it. You might have a problem that can be solved when you visualize the data, you can see the pattern, yeah, and conclude on something that is very positive. So these are the other task for a full stack data scientist is to deploy the model to production. Like as a full stack data scientist, you should know how to deploy and to work with different deployment tools and technologies that are there. Yeah. So I will mention free services that you can deploy your model. So here, a few of them is maybe we have data.sh. We also have Heroku. We have Python everywhere. We have digital oceans app platform. We have AWS. We have a lot of them. So and so on. So these are places where you can deploy your machine learning model. Okay, this is not a jargon. Deploying a machine learning model, it's just like creating a machine learning process model or algorithm, turning it to an API and creating a website endpoint and calling it from the front end. Like let's say you're trying to predict something and you feed the data. Now you can develop web forms where when the data is sent, what happens? When the data is sent, what happens is that you can be able to input data. It sends the data. The machine learning algorithm that is there evaluates and give the correct prediction. It gives you back the correct prediction on the front end. So about linking the business to machine learning and not machine learning solutions and deployment of machine learning models to production are the two elements that are key to any organization extracting value from data science and solving the right problem and making them accessible to the end user. You can't make a machine learning model that is existing on Jupyter notebooks or Jupyter Labs or Google Colabs to the head user. You have to deploy it. So we can move to the next step. Here is where we start with. Okay, before I do that, I will elaborate more about deployment here now in these questions. Let me share. Can you see my screen? Can you confirm so that you can go on data science?
Yes.
Yeah, now here is where this was our main agenda for today. Yeah, solving all these questions. But before I go on, I want to solve something. Yeah. Now I'm here and I'm using high-risk dataset. Just give me 1 minute, I'll be back. 1 minute. Hey, I'm back. Can you see my screen so that you can go on? I want to explain the process of deploying a model.
Yes, you can see your screen.
Thank you. So we have this data here, and it is the iris data set. Okay, I used Seaborn, and Seaborn contains inbuilt data set, which we also call them toy data set. Okay, so these are the two. Okay, this is how you import that data from Seaborn, but I don't want you to pay attention to that right now. I want you to pay attention to the data set. Can you see the 4 columns that you have here? The sepal length, sepal width, petal length, petal width, and the species. So in iris dataset, we have 3 species of flower, and each contains each has 50 rows. Yeah, and we are supposed to give the sepal length, sepal width, petal length, and petal width to predict the species of a flower depending on the specific properties that you have passed. So if I was to develop a problem with this and deploy it, I'll create a web application that has 4. So I'll use sepal length, sepal width, petal length, and petal width to predict the species. So I will develop a web application that has 4 input in forms. So I will create a web application, maybe using Flask, maybe using Django, maybe using Fast API. Then I will include a form, and inside that form, I will have 4 inputs so that I can input the sepal length, sepal width, petal length, and petal width, so that I can get the species of that flower given on the dimensions that I have given. So deploying a machine learning model is not a big deal. It's not something that is very big. We just have to think. So anyone with question about machine learning deployment process, maybe we can answer that before we go on. Anyone who want clarification? So you think we can go on if there is no any question? Okay, let's start with these questions. We'll try to cover them as fast as possible. We will not be able to do all of them, but I will send you the link. Okay, I even think I sent you the link to where you can get them. I will share the link again if, yeah. You can get all the questions from that repository. And if you think you can contribute to more questions that you think I'll ask in any data science interview, yeah, you can just send me an email or text me. Yeah, and I will hand you as a contributor to the GitHub repository. They are found inside an organization, Data Science East Africa organization, GitHub organization. So you can text me there, or you can text the Data Science East Africa WhatsApp number 2547949834. And it text Data Science East Africa next Africa on their WhatsApp number that I've given there. And they will reply and add you as a contributor to the GitHub organization. And then you can contribute to the any GitHub that you want, in a GitHub repository that you want. So I think I'll begin with the questions. And some of the common questions that you be asked is, what is data science? Yeah. What does a data scientist do? But we have covered those. So I think we don't have to repeat them. And I started with the general questions that you might get, eliminating some of the questions that we have covered by now. in the session. So some of the questions that you'll be asked is, give the differences between supervised and unsupervised running. So those are basic questions which I think almost everyone knows. How do you want to do this? Can I stop sharing the screen? What my thinking is, I stop sharing the screen. I'll be typing the answer on the chat box. Then people can try answering. Then after answering, I can give the correct answers. Or I can share the notes. Okay, or I can share the notes and we discuss them together. Which do you think fits best? Hey, at least two people to give their input. What do you think we need? Can I share the slides and we discuss together, or I can be asking the question, we discuss together and move on? Which is the best way to do it? Okay, yeah, I want to see this. When I will share my screen, I want to be able to see this page. So don't type in a question. If you have a question, unmute your mic and ask the question. You know, if I share my screen, the slides, I want to be able to see this page. You're typing your answers. So I will do that. If you have a question, just unmute your mic and ask. So these are the common answers that you can give when asked the differences between unsupervised and supervised. The first one, you know, the uses labeled or known data as input. Whereas in cases of unsupervised running, you uses unlabeled data as input. The other question that you get, the other feedback that you can give or answer is, you can see that supervised running as a feedback mechanism, while in cases of unsupervised running now, where you meet, you don't need a feedback mechanism in unsupervised running. Then you can also support your answers by giving the common machine learning algorithm that can be used in supervised running, and give some of the common machine learning algorithm that can be found in unsupervised running. And when I come to supervised running, these are some of the most commonly used machine learning algorithm in supervised problems. The first one is decision trees, there is logistic regression, there is support vector machine. While you come to unsupervised running, you meet something like k-means clustering, hierarchical clustering, or a priori algorithm. So I think we can move to the next question if there isn't any clarification that you need.
I have a question. What do you mean by a feedback mechanism?
Okay, I will first by tell you, do you understand what is labeled data? Like labeled data, you have what you want, what you are importing, and what you want. So everything is well known. But in unsupervised running, you don't have everything there. So when I say that you need, there is a feedback mechanism. Okay, it's like I'm asking you a question so that you can give me an answer depending on that question that I have given you. Now, because you know the data, there is approximate values that you need, or there is approximate prediction that you need. Now, that is where you meet the feedback mechanism. You ask a question expecting an answer that ranges from somewhere to somewhere. If I'm clear, I can move to what is logistic regression. This is one of other common questions that you get. It is asked very often. And you have to know that a logistic regression is also known as logistic model. So I might ask you what is a logistic regression, or you meet me in other months and I will ask you And I will ask you what is a logit model. Let me type. Yeah. So those questions refers to the same machine learning algorithm, and it not algorithm, sorry. Logistic regression and logit model are like synonyms, and it is a techniques used to forecast the binary outcomes from a linear combination of predictor variables. Okay, when you talk about logistic regression, you're talking about binary, you're forecasting or you're predicting binary outcomes. And they might add something. Apart from asking you what is a logistic regression, they might ask you, how do you do a logistic regression? So you have to know what logistic regression is used for first. So you can tell them that a logistic regression measures the relationship between dependent variables. These are our labels of what we want to predict, okay? And one or more independent variables, or our features, by estimating the probability using the underlying logistic function. Okay, someone might ask you, what is a logistic function? Or instead of asking you what is a logistic function, they will ask you what is a sigmoid function. So you have to know that a logistic function is the same as sigmoid function. And talking about dependent and independent variables, these are also called labels and features. So that is the reason I loaded this data set here. Who can give me, okay, I loaded the data set, we will discuss this later, but I have this type of data set, that is iris data set. It is available on Kaggle, so it is inbuilt, or it is part of the toy dataset that is there in Seaborn. So you see, you have sepal length, sepal width, petal length, and petal width, and you want to predict maybe the species, and you'll use these four to predict this. So which of them is the independent variable, and which of these are our features? Or, okay, which of them are independent and which are dependent variables? Or in other question I might ask, which of them are labels and which of them are features? Can you answer that? Do you know? Do you have an answer for that? Anyone? Just unmute your mic. Give me.
Yeah.
So the length, width, those are the features. Then there's something that we want to predict is the label, the species.
Thank you. Yeah, that's correct. So as he has said, I don't know his name. So these are the features, and they are also called independent variables. And this is the label, the species part. This is the label. It is also called the dependent variable. Okay, understand it like this. This, to get the prediction, it relying on something is depending on something. So that is why it is called dependent variable. It is depending on others. Independent variables, they don't depend on the species. They can change their value independently. That is why they are called independent variables. That's just a simple way of understanding it. So the other question that you might get is, you ask to explain steps used in making a decision tree. How do you make a decision tree? Anyone with a clue, or I should go on? Okay, first of all, you should understand first of all, you should understand what a decision tree is. And back back of your mind, you should have how do a decision tree looks like. So I might ask someone, I don't know if you're in a position to do that. Francis, are you in a position to share the decision tree that you are looking at? Francis, are you in a position to share the decision tree? Kindly. Okay, as you wait for him to answer the question, you can move on. And I'll be discussing how you do, how do you do, or how do you create a decision tree. The first one is you take the entire data set as inputs. Then after taking the inputs, the next step that you do is look for a split that maximizes the separation of the classes. A split is any test that divides the data into two. Yeah. So you look for any test that divides the data set into two and maximizes the separation of the classes. Then you apply the split in the input data. This is the divide step. After that, you reapply step 1 and 2 to the divide data, to the divided data, sorry. So after dividing the data, now you have two data, now you keep dividing it. After, maybe let's take an example, like you're divided into two, then now you take the each as the entire data set, then you divide it again. You keep doing that until you reach a stopping criteria, or you meet a stopping criteria. And this step is called planning. Clean up the tree if you want, if you went too far doing the split. If you pass the stopping criteria, make sure that you clean your data. I think it is clear. I'm looking at your feedback on the chat box or any question that you have. Okay, let's move to the next question. Okay, before I go, I can show you a decision tree so that you have what I'm saying. Decision tree. Yeah. We can look at a good decision tree like this one, but no, it's not a good one. I want to discuss just the first one. Now, you see, after advising campaign, can you see? Or maybe I can open it in a new, tab. I can't save an image. Now, this is an example of a decision tree. Like, let's say here you have your whole data set about an advertising campaign. Then now you divide it into two. Now you treat Facebook paid ads and Instagram sponsorship as each separate or full data set again. You keep dividing it until you reach what we are calling a stopping criteria. Then the process, you have to know that the process is known as pruning. So these are the basic terms that you'll use so that at least they can understand that you have some background knowledge about what exactly you're doing, or you have some background technical knowledge about exactly what you're doing. So the other question that you might meet in your interviews is, what is the feature vectors? Anyone who has ever come across feature vectors, and please don't give the explanation that I've given. Just give us a brief explanation. What do you think is a feature vector?
I think to be able to do machine learning, every feature needs to be like numerical. So anything that is categorical, you can convert it to numerical by doing any encodings, like label encodings, one-hot encodings, something, things like those.
Yeah. Thank you. Thank you, Victor. So let me unmute myself if I'm mute. So yeah, I think I'm not mute. So we can move on to talking about what are feature vectors. So a feature vector, you can define it as an n-dimension vector of numeric features that represent an object. Okay, and in machine learning, okay, this is basically what a feature vector is in general. It is an n-dimension vector of numeric features that represent an object. And in machine learning, feature vectors are used to represent numeric or symbolic features, characteristics, code features of an object in a mathematical way that is easy to analyze. Then one of the most popular question that you'll be asked, so that they know if you basically know the categories of product that you can do, is a recommender system. They might ask you what is a recommender system. So you have to know that a recommender system is a subclass of information filtering system that are meant to predict the preferences or rating that a user would give to a product. An example is the famous recommender system for Netflix and I think Amazon. If you buy a book at Amazon, not necessarily even buying a book at Amazon, if you look at a book, maybe you Google and you want to know something about a book, and maybe you want to buy a machine learning book or machine learning using C++ book, and you Google search. The book you're given, it costs maybe $45. There at the bottom, you'll see other recommendations that are given. Like they say, a viewer who bought this book or who viewed this book also viewed, or they might say other books that might interest you. The recommender systems are used to, okay, recommend for you, or what can I say, suggest for you an alternative of the product that you are viewing currently. It's alternative, or if you like the product that you are viewing currently, you might also like this. So that basically is what we call a recommender system. And technically, so that you can define it technically the way the business person will understand. So you have to mention that it is a subclass of information, at least mention that it is a subclass of information filtering systems. And you can say they are meant to predict the preferences. How much do you like something? Or how much would you rate a given product? Okay, I will also like to give you a few examples of systems that you can build using machine learning before I move to the next question, example. So I'll give you examples of smart systems that are existing. Some of them have interacted. The guys who are building have helped some to build some models. The first one is smart. Okay, I won't mention that. So we know about recommender system. I won't repeat that. Maybe I can start with smart advertisement. Smart advert product. So I'm not giving you this as examples. I'm giving you as business ideas or ideas, machine learning ideas that you can implement. A smart advert product. Okay, this is, I'll give you a good example with one that is in use in Nairobi currently. It is a smart advertisement. It is around Nairobi. Yeah, around University of Nairobi. And the smart advert system, it gives advert. These are the advertisement screens that you see on the street. Now, this system is built in such a way that when it sees a certain person, maybe what time is it? Maybe it's lunch time. So it predicts something according to time. So the one that is existing that is already in production, how it does thing, when it sees a car, it helps predict, or the advert that it gives as something that is related to specification of that car. Like they saw a car, maybe it is a, let's say it's a V8. And you know, someone owning V8 has a lot of cash. So the advert that you give to the driver or someone with that car is maybe something that is in its category. So what you can do with that advert is this. Maybe you can build another system using the same idea, and maybe the same price advert, maybe in the morning, you can be advertising the best cafe that can give the best coffee or breakfast. If it is lunchtime and you know people are hungry, they want to eat, you can advertise the best pizza in, okay, FC that is available, or Galitos that is available there. The other thing is maybe it is coded, the model can predict it is foggy. So it can predict a place where a person can get the best book around, the best clothes for cold seasons. So that is an example of a smart advertisement system. Yeah, I can see Victor told us about the credit recommendation system. We have fraud detection systems. Another example is application of machine learning in agriculture. I will give you another idea of how you can apply that in agriculture. Now, let's say you've seen, maybe you have visited some farm and you've seen maybe cassava, maybe maize, maybe wheat, maybe pineapples. They are being affected by a certain disease. So what you can do with your machine learning skills, you can build this model such a way that, okay, the data set is available and I'll be giving you sources so you can get the data set about maybe agriculture. So if it takes a certain photo, it can predict the type of the disease that that crop has, and it can also recommend the chemicals that you can apply to that plant specifically to cure the disease that is affecting it. Another way is where you fly maybe a drone that can capture everything that is there in that farm, and maybe it can give you the part of the farm according to the characteristics of the leaves and maybe the quality of the product that you have in that farm. It can give you the part of the farm that has a certain disease. And so that when you're applying maybe it's fertilizer or any other farm input, you don't apply to every part of the farm. To be economical, you only apply to the part that the machine learning product or the AI product recommended means a certain mineral. You might meet in a farm this part of the farm because it is maybe a large farm. This part of the farm, it doesn't have some minerals, but the other part of the farm has minerals. As mineral A, but it is deficiency with mineral B. So when you're applying, you don't apply the whole part of the farm. You apply the farm input where it is required. About the project I'm talking about, you can get the data set here. If you go to Cargo and look for plant disease, data set on Cargo, you'll get very large data sets here. Some even, okay, the official one has around, 3 GB, but I think the one that I've opened has 1 GB, the amount of data set that is there. I have a lot of data set available, so you don't have to worry where you get the data. Yeah, now you see this has 1 GB of data. If you are questioning how you load your 1 GB data set on Jupyter Notebook or anything, you can use maybe an API to access the data. Yeah, I'll be sharing the two links on the chat box so that you can look at it at your free time. That is where you can get all the data set about any plant disease. Even I see UCI, the University of California Machine Learning Repository, has that data set about the same new plant disease. So you can get the common asked questions and answers to the questions about the on cargo. And basically they were trying to answer that question here on plant disease. So you can get the answers here about the plant disease dataset that is available. Okay, I've given you two examples. You can look for another one. Yeah, I have a few more, but in the interest of time, we can move on. Because I'll be sharing this, I'll move maybe to the most important questions that I think are necessary. Another question that you need to know is what is the goal of a A/B test? But before answering and knowing what is a goal of a A/B test, you should understand what is A/B test. So basically, the goal of a A/B test, or you should understand that a A/B test, this is a statistical hypothesis testing for randomized experiment with two variables, variable A and B. And the objective or the goal of a A/B test is to detect any changes on a web page to maximize or increase the outcome of a strategy. So you have to know an A/B test. What is it? It is a statistical hypothesis testing for randomized experiment with two variables. Variable one is A and variable B. So you have two variables. And about those variables, you have to know that the objective of an A/B test is to detect any change to a web page to maximize or increase the outcome of a strategy. I will ask this question because I've discussed. When do you think you can use you are employed as a data science engineer in a very cool farm? When can you use an A/B test? Cases or scenarios where A/B test can be used. Please answer that. Maybe you can unmute your mic and answer. Scenarios or situations that you think you can use A/B tests. I'm still waiting for your answers. Anyone with another trial? Okay, I can see a lot of examples. Maybe I can link you to this person. She is called Emma Ding. She's currently a data scientist at Airbnb. She has written quality materials here on Medium. Yeah, she has even a YouTube channel which I can't get. Let's look if you get it here. She's currently working as a data scientist at Airbnb. Let me share this before I give you examples of places, I think. Yeah, even this is exactly the video that I was looking at about her commonly asked question. You can look at them at your own different. So I'll give you an example of an A/B test that she gave. Maybe you want to implement a feature here in your website and remove an existing feature. Now, that is a good case or a good scenario where you can apply an A/B test so that you can implement the new feature maybe to a few users. They can give you the feedback, and after having that feedback, now you can know, is it appropriate to implement the feature, or will it lead to increase maybe to the users when you implement a certain feature in a web application? That is a good example of an A/B test. So we can move on to a question. Yeah, this is the most ignored question, but I've found it in a lot of different interview sessions. Like they will ask you, what is the law of large numbers? It is taught in discrete mathematics, those who have been through the university curriculum. If you learned discrete mathematics, you must have the basic understanding of laws of large numbers. Who wants to try laws of large numbers? Okay, it is a theorem that describes the result of performing the same experiment very frequently. The theorem forms the basis of frequency style thinking. It states that the sample mean, sample variance, and sample standard deviation converges to what they are trying to estimate. So you should give them what it is, like telling them it is a theorem that describes the result of performing the same experiment very frequently. Now, you can tell them what it states. It states that the sample mean, the sample variance, and the sample standard deviation converges to what they are trying to estimate. There is something else that is taught at campus and still you meet it at any data science interview. I'll be back to confounding variables, but before we do that, we can look at the star schema. Who has a good definition of a star schema? Anyone who wants to try? Hey, people, try. What is a star schema? The data. If you do database management systems at campus, you should be aware of what is a star schema. Anyone want to try? I'm waiting for an answer on the chat box. Anyone want to try what is a star schema? In the interest of time, I'll define it and we move on. So it is a tradition database schema. So it is a tradition and it is a database schema. Okay, or you can say it is a schema found in tradition databases with a central table. Centralized table maps IDs to physical names or description. and it can be connected to central fact table using the ID fields. These tables are known as lookup tables, and they are principally useful to real-time applications as they save a lot of memory. So sometimes star schema involves several layers of summarization to recover information faster. So when you define star schema, also I thought it is important to include this, telling them that a star schema involves several layers of summarization to recover information faster. And the other question that they might ask you, but this is basically asked if you are going for maybe an advanced data science program, job opportunity. They will ask you how often or how regular must a machine learning algorithm be updated. Who has a quick answer for that? So if you are asked, okay, I'm looking if there is an answer, but you can't get one. So basically, you'll want to update the algorithm only when you want the model to evolve as data streams through infrastructure. The underlying data sources is changing, or there is a case of non-stationary. Okay, a case of non-stationary is when the data keep changing, or also when the underlying data source changes. You trained with a certain data set and the data source changes. When you're getting the data now, it changes. Now, here you need to have, or maybe you need to do now, an update to your machine learning algorithm to make sure that it gives the correct prediction. Maybe I can say that. And what the model, when you want the model to evolve as data streams through the infrastructure. So let's go on and look at one of the mathematical questions that is asked every time. So the question will be, what are eigenvalues and vectors? What are eigenvalues and eigenvectors? So you have to know that eigenvalues are directions along which particular linear transformation acts by flipping, corresponding, or compressing or stretching. Eigenvectors are understanding linear transformation. In data analysis, we usually calculate the eigenvectors for correlation or covariance matrix. And there is a way to calculate there is a way you can calculate eigenvectors using pandas in Python and NumPy. You don't have to do it mathematically the way you did it there. I want to show you how you can get eigenvalues and vectors in pandas and NumPy. But it is very important to understand the process of how you do it. Yeah, this is an example, but I wanted to give you just one that will give you answer. Yeah, I thought I saw this and an answer. So you have to create your matrix. No, you can get any from here. Yeah, you can get an answer from your matrix now. Yeah, this process now. Instead of calculating it manually, you can just feed your data set and get the output from NumPy. Maybe I can share this resource. You can look at it later. But understanding basically what an eigenvector is very important. So basically, for first learn and understand what is an eigenvector, and I've said, you understand what is an eigenvector and eigenvalues. And I've said eigenvalues are directions along which a particular linear transformation acts by flipping, compressing, or stretching. If you compress or you flip or you stretch a matrix, which direction will it move in? So about eigenvectors are for understanding linear transformation. If you want to understand in a linear transformation in a data set, you make use of eigenvectors. And in data analysis, we usually create eigenvectors for a correlation or covariance matrix. We'll look at it in another question. Now, this is the process. I won't be discussing it, but you can get the whole process. If you want, I explain, maybe you can still. Okay, I shared my details here for Next Africa. I will share it again. If you want any clarification about how to calculate eigenvectors using mathematically, you can look at it there and later. You can text that number on WhatsApp, you'll get a good explanation what eigenvectors is really. He said, how can you calculate it? But I think understanding is the first step. And maybe you should know how to calculate determinant of any matrix, may it be 3 by 3. So the first step when you are calculating an eigenvector, when you are calculating eigenvalues, you start by calculating the determinant of a matrix. Then after that, we have an algebraic equation built for the eigenvector. So you build an algebraic expression from the eigenvectors. Then now the next step will, this is how you build the algebraic expression. Then you calculate the eigenvector of lambda. Now you get the value of A, the lambda that is there. Okay, basically calculating the determinant of any matrix. Now that is where you introduce the lambda. I think it is self-explanatory. After calculating, you get the value of lambda. And getting the value of lambda is getting the values of the eigenvalues. Then now you come to substitute them in the equations that we had earlier. Okay, another important question you have to understand is what is resampling and how is resampling done? But I think that is self-explanatory. Like resampling is the method that consists of drawing repeated samples from the original data samples. So you're repeating the sampling process. Now you have to understand what is a population and sample before understanding what is resampling. So population is the total number of entries or the total number of data under study. Then now you understand the sample is a portion of that data set. And you have to understand the two things that we have, the large and small samples. It's very important knowing if you're given a certain sample, is this a small or a large sample? After understanding the sampling, okay, I think I will repeat again if I moved very fast. Resampling is the method that consists of drawing repeated samples from the original data samples. And this is how resampling is done. Resampling is done in, okay, sorry, I asked the wrong question. So I will also answer how it is done. But why is it done? Why do you do the sampling? Or why do you have to repeat the sampling process? Well, as you did it. Now, you do the sampling in either of these cases that I will read when estimating the accuracy of sample statistics by using the subset of accessible data, or drawing randomly with replacement. Like you're drawing probability, or you're drawing the sample randomly with replacement from a set of data points, substituting labels on data point when performing significance tests, validating models by using random subsets. That is also called bootstrapping. Or the question that we passed that was asking what is cross-validation. You look at it. So the other question that is important is what is a selection bias. You have to know that a selection bias is a problematic situation in which error is introduced due to non-random population sample. Also, you have to know what are the types of bias that can occur during sampling. When you're doing sampling, how many types of what are the categories of bias that you can get? So we have selection, we have undercoverage, and we have supervisorship bias. So there you have to know this. At least you should understand all of them. Now, the essence of asking you one of them here down, after asking you the types of bias that are there, the person wants to understand, do you really understand all of them? So you can randomly pick one, not necessarily the one that I have included there. So you have to understand the types of biases that we have and understand each of them. Take with, okay, another thing I would like to say when you're giving any explanation in a data science or any technical interview session, make sure that you include specific technical terms. Like if I ask you any question that means, okay, just try to relate with any technical term that you ever learned while you are trying to do research on a certain field or specific field. So the other thing that I wanted to look at, I want to ask you this. I wanted to ask you this. Which of the following machine learning algorithm can be used for inputting missing values of both categorical and continuous data? Now, what basically they want to know, do you know which machine learning algorithm can be used in categorical and which can be used in continuous variables, and which can be used both in categorical and continuous variables? So that is their main goal when someone is asking you which machine learning algorithm I can use for inputting missing values of both categorical and continuous variables. So, and you're given a sample, they give you a random sample of machine learning algorithm. Now we have, okay, I will ask you and I want you to answer this, please. Don't go silent. So, like if you meet clustering problem is applied in which machine learning problem? Categorical or the one containing categorical or the one containing continuous variables? Can you answer on the chat box, please? When do we use K means clustering? Is it supervised and unsupervised? And if it is supervised or unsupervised, which type of data does K means deal with? Is it continuous or yeah? Yeah, I think the first two person give the correct answer. So I'll move to the next machine learning algorithm, linear regression. When do we use linear regression? The answer given by Joseph Kedome, that is wrong. Yeah, I can see Nyaga told me we use linear regression in supervised learning, but is it when you have continuous or categorical variables? When will you use linear? Okay, We can move to the next machine learning. I won't mention this first. When do we use decision trees? When do we use decision tree? Yeah, Christopher Nyaga, Francis, and Victor gave the correct answer. We use linear regression in supervised problems where we have continuous variables. So when do you use decision tree? Decision tree, machine learning algorithm, when will you use it? Hey, waiting for those answers from at least 3 to 4 people so that I can go on. Yeah, Francis, Christopher Nyaga. Yeah, they are giving the correct answer. You use decision tree in terms of in situations that you have supervised categorical data, sorry for that. So, and now we leave the answer to K means K nearest neighbors. When do you use K and N? K nearest neighbor. When do you use K and N? I'm waiting for those answers. Yeah, now there is where we start the debate. Unsupervised, supervised, unsupervised, unsupervised, unsupervised. Yeah, thank you. So I think I'll now move, yeah, both. Now, when you talk about K nearest neighbor algorithm, it can be used because it can compute the nearest neighbor. And if it doesn't have values, it just compute the nearest neighbor based on all other features that we have. When you are dealing with K-means clustering or linear regression, you need to have that in your pre-processing. Otherwise, the system will crash or the algorithm will crash. In situations of having a decision tree also have the same problem, although there is some variance in decision tree. Also about this, because I've seen the situation here, this is the good time that you have to explain what is an example of an ensemble learning ML. I've asked this question severally. So if you basically understand the meaning of an ensemble machine learning, you can explain to us. Unmute your mic and give an explanation. What is ensemble machine learning? No one wants to give a try. Okay,
Okay, I think is
yeah. Go on, Christopher. We are listening.
okay. I think is a group of machine learning models grouped
Yeah.
together and like they are given like you calculate the average or something like that.
Who has an answer or him being different from that? Okay. Who else wants to try? Just try. Okay, I can see Francis typed an answer. Okay, someone else is giving an examples. Yeah, thank you. So you can look at and okay, yeah. Also, Kidome gave an answer. He said Ensemble methods is a machine learning technique that combines several base models in order to produce an optimal predictive model. Thank you. So in the interest of time, we have around 5 minutes remaining. We won't be able to cover every question, but at least I'll read them so that if you have a specific question that you want answered, you can answer. So I'll start at the bottom. Well, you should understand what dimension reduction is, and you should give at least one benefit of a dimensionality reduction. Also, for a given point, how do you calculate Euclidean distance in Python? You should know how to calculate Euclidean distance using Python. Yeah. Then you are given a dataset consisting of variables with more than 30% of missing values. So how will you deal with a dataset that has values that has more than 30% of missing values? You have two basic ways of handling missing values, and you have to know you handle missing values in a dataset depending on the size of the dataset. If you have large dataset, you can drop that row that has missing values. But in case you have missing values in your dataset, what you have to do, you can't drop dataset in an example that has a small dataset. Okay, you have to understand how to build a random forest model, and you should at least know the basic steps of building a random forest. Okay, which other question we didn't answer? We answered about resampling. I said you look at values of how will you calculate the various eigenvalues. For a 3x3 matrix, you should also look at how to calculate eigenvalues for a 2x2 matrix or any given matrix that you have. Like, how do you calculate the determinant? How do you form the algebraic equation that you are required to use to get the values of eigenvalues? You should understand how regularly should you update your machine learning algorithm that is in production, and what is a star schema. You should look at it. I said we look at the confounding variables. Okay, these are extraneous variables in a statistical model that correlates directly or inversely with both the independent and dependent variables. So you have to know that confounding variables correlate directly or inversely with both, not only one, dependent and independent variable. The estimate fails to account for any confounding factors. Laws of large numbers, I said, make sure that you understand. Laws of large numbers is a theorem, and it is a theorem that is used to describe the result of performing the same experiment very frequently. Also, the other thing you have to understand about it is, what does law of large numbers state? You have to know that it states that the sample mean, the sample variance, and the sample standard deviation converge to what we are trying to experiment. You have to know the drawbacks or why you can't use a linear model in some situation. You have to understand what is a A/B test and the goals of A/B test. You can use the guide that I sent you from Hemading. Then you have to understand, does graded descendant method always converge to similar point? Okay, you have to know it doesn't, and you have to know why it doesn't converge to similar points. Collaborative filtering, you have to know what it is. You have to know to explain cross-validation. Okay, it is a model validation techniques for evaluating how the outcomes of a statistical analysis will generalize to an independent data set. So you have to understand what basically cross-validation is. You can look at it here. If you have a question, you can text the number that I gave the app. Then we have, after understanding cross-validation, yeah, recommender system, we looked at it. We looked at the feature vector. After that, we looked at the steps that are used in making a decision tree. We also looked at how is logistic regression done, what is logistic regression. We looked at supervised and unsupervised learning. We understood the data science process and how to start data science. Then we looked at the full stack data science. What basically is full stack data science? And I think for now you have covered the objective and we are 1 minute left. We are 1 minute to 8, sorry. So I think one thing else I can share is a GitHub repository that will help you. Apart from this, okay, there is this that I shared. You can also look at Data Science East Africa GitHub repository. I said if you want to be a contributor, you can just email me. We can look at how you do it. Yeah, you can contribute to any repository that is there you think you can add, so you can have a look at it. The other thing that I want to share is this repository on data cleaning. Just 1 minute, please. Yeah, maybe a look at repositories. On repositories, look at data cleaning using Python. It is a very good, exhaustive, how you can clean data using pandas. And as I've said, if you want to contribute in a GitHub repository that is available in Science East Africa. I think we are done. Before I do that, let me share something else. Okay, at Data Science East Africa, we are introducing C++ for machine learning. But we first want you to understand the basic of C++, how you do C++. That's why we are trying to start writing GIST and repository that will help you to understand and compare. Now, this guide, the one that I'm sharing currently, it will help you to understand and compare how to execute, outright functions, outright variables, how to execute your program in C++. Yeah, the last thing that I would like to share. Okay, I think I've shared everything that was required. If I still have my program learning. Okay, there is, why do we need C++? You know, understanding C++ is understanding programming. Like you have to know in C++, if I was writing a Python program, maybe I created a file called app.py. I was not prepared to say this. If I want to run this file on the terminal, I'll just run Python. Maybe I'm using Python 3, app.py. It will give me the result directly. But when you're working with C++, it is a different case. Like maybe you're using G++ to execute your program. So if you created a file called app.cpp, to execute it, you maybe use this tool to execute it. Then it will give you a file. What it gives you is a file that is an output file that that contains the machine language, not running, alternative of your source code. Now, to get the output of your source code, now you have to execute this output file. Maybe I can show you an example for those who want to remain. I think I have an hello world example here. Like understanding machine learning is okay. Understanding C++ is understanding programming in depth. And as I said, programming is very important. You're seeing on my screen. I expect that. Can someone confirm? You can see on my
Yes.
screen. Okay, thank you. Now look at what happens when you execute a Python C++ program. I have a folder here. There are a lot to know when you learn C++ in them. You can just dedicate maybe 2 months learning C++. That will make you, or it will help you to stand out. You can see my terminal, right?
Yes.
Hey guys, can someone confirm if you can see my terminal?
We can see.
Okay, now I want to move to the file. Okay, I think now I can close the, yeah, maybe I can clear move back once and move back again. And you can see this folder that I've opened on the terminal is the same folder that I've opened on my files. So it looks like this. And inside I have hello world program. Yeah. Inside I have this program, to program. This is the first one and this is the second one, sample. Yeah, they are both hello world programs in C++. Now, this is the files that I want to execute. Maybe I want to execute the app.cpp. So to execute it, I will use the app.cpp. If I compile that source code, I'm expecting it to give me another file that now I will execute to get my output. You don't get the output by executing the source code. Now you can see in my folder, there is a file that was added. And this file is the one now that I have to execute so that I can get the output that is there in my, yeah. Now, when I executed, I expected to get hello world, but I didn't get it. I was given an output file. Now I can try maybe to execute that file using this syntax. You can see it give me the output hello world, which I expected when I learned the code. If it was a Python file, it would be very fast. I don't know if you understood, but you look at it when the bootcamp starts, it will be on machine learning using C++. You start by learning what basically is C++, then you understand what is machine learning, and then move to using C++ for machine learning or doing machine learning problem using C++. Okay, guys, I would like to thank you for availing your time to listen to us. And the other thing that I would like to mention is you can follow Next Africa. They are the people who supported today's program, Next Africa, on Twitter. Also, they have a GitHub repository. You can check them. Yeah, anytime that you need, you can follow them on Twitter. Thank you. The meeting is over. I think I can just reshare this Twitter handle for Next Africa so that if you're interested, you can join. You can follow them. They have amazing opportunities. And basically, they're interested in building smart systems, smart softwares. Everything has machine learning. Anything they do, progressive web applications, anything that they do has machine learning. Okay, thank you. The meeting is over. Unless you have a specific question for me, you can maybe remain back. Yeah, thank you, Samuel. You can leave maybe.
Thanks for the session, Harun. Thanks.
Thank you.